This topic is getting started with observability using OpenTelemetry and Grafana. I think that's how you say that. Okay, good. And we have here the wonderful Connor Lindsey. Connor is a software engineer with experience working at AWS and Rivet. He is currently working as an open source software, or a software engineer, wow, I don't know where my mind went there, at Grafana on the observability squad. So let's give it up for Connor.
So this week we saw outages from Facebook, NPM, shows the importance of having observability in place to respond to any inevitable outages or slowdowns that our applications might have. So like was mentioned, I worked at AWS working on OpenTelemetry, Rivet as a full stack dev, where I saw the importance of having good tooling in place to respond to errors and outages, and I'm now working at Grafana Labs as a software engineer on our tracing platform. So one metaphor that helps me understand observability is that of driving a car. When you're driving a car, you need to understand the status of the system you're working with. You know, how much gas do you have left? How fast are you going? Are there problems with your engine? And so the dashboard and different parts of your vehicle will give you information about that, you know, show you how fast you're going, maybe the check engine is light, you know, that you need to go get some repairs done on your car. For those dashboards to work, you need to have data and sensors sending that data over to the dashboard. And the same thing applies to software systems. You need some way to collect telemetry data and send it to an observability backend, which will give you tools to query and visualize that data to understand the status of your system, to understand, you know, which API endpoints are having errors, which of your web servers are the slowest, things like that. And talking about observability data, there are 3 types of signals or data types that we're mostly concerned with. Those are metrics, traces, and logs. Each one gives us a different view at the same underlying system that we can look at to answer different questions. So looking at metrics, these are aggregated and quantitative data, generally used to see dashboards like the one that we see up on the screen. They're good at giving you a high-level overview of what is happening and possibly how bad is it happening. So you're able to visually see, okay, at 135, there was a huge spike in server latency. What's going on there? Generally, with these dashboards and metrics, you're also going to configure alerts. You know, if your error rate goes over X percentage, ping a Slack channel so that whoever's on call can respond to that issue. Because these are aggregated data points, you lose some details, but that's why we have these other types of data, like traces and logs, to give a complete picture. So with traces, like a stack trace, it gives you a record of a request as it passes through your system. With observability, though, it'll be a distributed trace, so it will show the path throughout different systems, so from your front end to your API to Redis to Postgres, etc. And that gives you rich information about how these different subsystems of your application are interacting with each other. And it gives you a good view of where is some incident happening. You know, where are your requests slower than normal? Where are errors occurring? But because it's a single data point, it's hard to get aggregate data from traces. And finally, the third signal we're concerned with are logs. This is a linear stream of events that gives very detailed information about what is going on in your application. And there are a lot of great log aggregation tools like Loki, CloudWatch, Elasticsearch, etc., that can be used to work with this format of data. So where these data points are really powerful in isolation, it is even better to have them all in one place so that we can bounce between them to paint that entire picture of how a system is operating. So if we see, you know, that spike in server latency in our metrics, we're able to jump over to our traces for those operations and see a specific example of why is this being slower than normal. You can pop over to your logs then to get more information about what's happening. And you're able to go back and forth between these data types to answer those questions. So that's where a platform like Grafana comes in. We're able to bring in open source or closed source data sources and create dashboards and visualizations of all those data types together. Grafana is based on an open source plugin architecture, which makes it really nice to bring in all of your data into one place. All of this up to this point has been, going back to the car analogy, that dashboard where you're seeing your data. But for this to work, you need a way to collect that telemetry data. One option for doing that is OpenTelemetry. It is an open standard for observability data. So it has a specification that defines what is a trace, what format does it come in, what are metrics, how do you collect them, what are the different types of sensors or instruments that you're able to use. And there are a bunch of other components that are used, like exporters, which will take the data from the OpenTelemetry format and send it to whatever backend that you're using, like Jaeger or Prometheus. So taking a look at this in practice, we'll look at a demo application. For the purpose of this demo, these specific technologies aren't super important, but on the front end, using Next.js, the Node API is built with Fastify, and the database is Postgres. We're going to collect traces and metrics and send them through OpenTelemetry to the respective backends, which are Prometheus and Jaeger. These are going to store and aggregate metrics and traces, as well as provide APIs to query and visualize them. A note on stability, OpenTelemetry is a relatively new project, so for the purpose of this discussion, I'll say that traces are stable and metrics are stable as well, but logging is currently in the specification phase. So we'll use other tools called Prometheus and Loki for logs. Prometheus is going to scrape our log files and send those over to Loki. So now to this point, we have all of our telemetry data, and we're able to use Grafana to visualize all of them together. So I'm going to switch over and look at the code briefly to show an example of what this looks like in practice. I'll show the slide in the end too. Let me zoom in a little bit. Okay, cool. So this application, everything is running from Docker Compose. If you want to after, you can clone the repo. I have a link to it in the slides. And you can see how everything is configured and connecting together. So with a single command, able to bring up the app, the API, database, everything to get the application running. And we can see in the folder structure, the most relevant folders are the API, for our Node API, and our app, our Next.js application. And we'll mostly be looking at the API. So I have this up and running, and we'll switch over and look at the UI. Pretty simple application. It is used to track transactions, like a balance of your accounts. So I went in, created a couple categories, created a couple of transactions. I think it generated some errors. So someone's using your application. How do we get the data into our backend, observability backends? That's what we'll take a look at now. So switching back over to the code, the most relevant file is server.ts in our API folder. And here we're instantiating our Fastify server and registering our endpoints, and then starting the server. Looking through the different data sources, I'll show you how logs are set up. Fastify uses, I think, Pinot as a logger. Just specify where I'm going to write out the logs to, and then Prometheus and Loki are going to go scrape those, and then we'll be able to get them in Grafana. So I'll switch over to Grafana. Here, under configuration and data sources, we're able to tell Grafana where to look for the data that we're interested in. I've set up Jaeger, Loki, and Prometheus. Looking at the configuration, it's relatively simple to get started. You select the type of data source that you're going to be using, and you give it the URL of where that instance is running. And then Grafana is able to go and look for that data, and then you're able to use it throughout your application. There's additional config for your different data sources to do things like connect them together. For example, this derived fields lets you use a regex to parse out different parts of your logs file, your log lines, and you are then able to link those either to internal data sources. So in this case, it says, if you see a trace ID and a log message, have a link over to Jaeger, so that when you see a log, or like, I want to see the trace associated with that, you can do that, or you could link to anywhere else. So I'm going to click on Explore, and that'll take us to the Explore page with Loki as the selected data source. Explore is a page where you're able to write ad hoc queries to play around with your data. Each of the tools that we're talking about have a query language they're able to use, and generally have a browser, which will help you write those queries if you're unfamiliar with the query language. So you're able to select the labels that you're filtering on, which are kind of like key value pairs to search on, write that. So simple query to pull up our logs for our API is job equals API. And I can run that for the time period specified. It will pull up the logs that we're looking at. Relatively straightforward. I think tracing and metrics are a little bit more interesting, although logs are super important to have when you have an issue and you're trying to figure out what was going on. So switching back to the code, I'll look at how we have configured tracing. So in our tracing config.ts file, we are going to set up the components that OpenTelemetry needs to track our traces. So we're going to create a global trace provider, and this is going to start and stop our traces and spans, as well as there's some additional configuration we can use, for example, a sampler. In production, you're not going to want to send all of your telemetry data, because that will be very expensive depending on how many requests or how much traffic that you're getting. For this example, we can send 100% of it, but in production, depending on your use case, you might only send 1% or even less of your traces that you're collecting to your backend. The next important part of this configuration is that we are setting up an exporter. In this case, we're telling OpenTelemetry, whenever you have traces ready to send them to this instance of Jaeger, and we give it the host and the port. There are a bunch of other exporters that you're able to use, even a standard out one that you can use to test your, just to log out your traces to make sure that everything is working correctly. So we have this all configured. The next thing that we need to do is set up our instrumentation, which is basically placing those sensors throughout the vehicle. Going back to the car analogy, there are two ways to instrument our applications. The first is auto instrumentation. Auto instrumentation is where we bring in a plugin or a package that uses some mechanism of the library that we're using to automatically generate traces or metrics. So for Express, for example, that would be like a middleware that would wrap all of our requests and start and stop a trace. In the case of Fastify, we're using this OpenTelemetry plugin, and we do server.register to hook that up. And then we tell it to wrap the routes. So every time we get a request to an endpoint, it's going to start a trace. When that's resolved, it's going to end the trace. So looking at that in Grafana, I'm going to switch over to our Jaeger data source. Here we're able to use this search panel, which is really nice, where we're able to select, based on certain criteria, what traces do we want to look at. So I'll click on Service, click API, run the query, and it will, if I change the time range, okay, there we got some data. Here you get a table of all the traces that fulfill the criteria that you have. Generally, when you're looking at traces, maybe you want to look at the longest ones. That might be the most interesting thing that you want to see. What happened that made that so slow? Like if we look at this request to the transaction endpoint, this GET request, took 5 seconds. What happened there? Whereas most of the other requests take like 50 milliseconds or less. So I can click on that, open it up, and see what's happening. In this case, I see that there's an error. I think not all of my services had started up when this was called, so it wasn't able to resolve and get the data that I needed to. So able to see something anomalous with how my API was running. Going back, I'll look at another one. This is GET request to category. So looking at the anatomy of this trace, there are two spans. The first is the root span, which represents the entire request to this API endpoint. So GET category. That took about 4 milliseconds to return. Then this child span shows a sub-operation. Something happened within that. This also happens in the API, but this could be happening in another service, like our caching service, for example. This operation was category.findMany. And I'll show you where this is collected. Because this first span is from that auto instrumentation we just looked at. The next one is something that I manually instrumented because I wanted to see how long our calls to our database are taking. So if I go over to prisma.ts, Prisma is an ORM that was mentioned in Kent's talk. And what I'm doing here, For manual instrumentation, you are grabbing that global tracer that you set up in the configuration and are able to call methods on it like start span and end span. It's a relatively straightforward API. I have some operation that's happening on my backend that I'm interested in learning about, so I wrap it in a span. I'm using something also to point out is that whenever possible, I'm using global mechanisms, I'd say, in the framework or the tools that I'm using to be able to instrument as much code as possible with as little work. So middlewares, hooks. In this case, I'm using prisma.use, which is going to wrap every request to start and stop a span. And that is how I'm able to get this data into Grafana. So a tiny bit of code, and I'm able to get all of these requests wrapped. There's other auto instrumentation. For example, if I was using PG directly to work with my database, there's an auto instrumentation for that. And it's just something that you install, you configure, and it handles it for you. There's auto instrumentation for GraphQL, for pretty much any technology you can think of. There's a great open source community focused on providing instrumentation and exporter so that all of your data, wherever it is, wherever you're collecting it from, you're able to easily set that up. So that's a look at traces. The next thing is metrics. Very similar in metrics.config. We're going to go through the same process. We're going to configure this global meter provider, which is going to track our metrics. It's going to track our sensors or instruments that we're creating and manage kind of this pipeline of collecting and sending off metrics. So here we have our meter that we set up. It will collect metrics every second and export them. We also set up our Prometheus exporter. Prometheus is a poll-based exporter. So basically, our Prometheus instance is going to call an API endpoint and scrape the metrics, whereas Jaeger, that we saw earlier, our API is actually going to send it to Jaeger. So two different mechanisms used by different telemetry backends. So Jaeger is pushing data to Jaeger, and for Prometheus, Prometheus is scraping data from our API. Just something to point out. And then from here, we kind of have two similar things where we're using, I would call it auto instrumentation and manual instrumentation. For this auto instrumentation, I write a middleware called count all requests. I'm going to use that. Whatever request comes in, I'm going to increment the request for that route by 1. Relatively simple. In my server, I am going to register that. Fastify uses hooks, so whenever this onRequest event happens, it's going to call the count all requests method. So that's kind of like an automatic thing that I'm setting up, that every request is going to increment the request count. The next thing are these other instruments that I'm setting up. So for the application, some of the data that we're interested in is like how many transactions have been created, how many categories, what's the current balance. So I create sensors or instruments for these, and then I'm able to use those in my routes. So if I go over to where this transaction gauge is used, for example, whenever I create a transaction, I increment it by 1. Whenever I delete a transaction, I decrement it by 1. Relatively straightforward example, and that's able to get some data into our application. And then a final thing that we'll take a look at is dashboards. So dashboards are probably one of the most common things that you're going to be doing with Grafana and your metrics data. I already have one created, so we don't have to go through everything for the sake of time. I'll change the time so that we get some data. Here in this dashboard, in the top 2 panels, we have some kind of app-specific data. We have the balance over time, and then the transaction and category count. So we're able to see, at 12:30, the balance in the application was $395. And we see the transaction and category count. Probably a more interesting thing, and what you would normally be instrumenting in an application would be something like request rate over time. In the last minute or so, I'll pop into this and show what it looks like to create one of these panels. So we have our visualization, and then down below, we have another query editor, like we saw on the Explore page. And we have this query that was built out. So we get all of the requests, and then we calculate the rate over 1 minute. So we're getting how many requests per minute we're getting, split up by the endpoint. Bunch of configuration that you can do, giving titles to the panels, setting limits, alerts. There's a lot of customization that you can get into to make this data work exactly how you want it to. Pop over to the slides to have this. I have a QR code with a link to the slides. This also has the demo app, which is at GitHub/ConnorLindsey/OpenTelemetry Grafana demo. Feel free to download it, play around with it. Come find me after. Would love to answer any questions that you might have about open source observability or any number of the great closed source options that we have. Awesome. Thank you all.